Hi guys, welcome to a quick walkthrough of the Delta Math, at least for part one. I'm just going to show you how to do the first three types of questions. So looking at the very first type, it's solving linear system graphically, where the graph is given. So notice, solve the system of equations graphed on the coordinate axes below. So before we get started, let's quickly talk about what a linear system is. We've worked with linear equations before. One linear equation, y equals negative 4x minus 1, that's one line. Y equals 2x minus 1, that's another line. Hopefully you remember that when the slope is negative, the line is decreasing left to right. Hence, we have the decrease here. And when the slope is positive, the line is increasing from left to right. Now, what we have in this question is technically a system. Why? There are two equations. A system of equations is basically when you work with two or more. So 2 or 3 is going to be our usual, but you are more than welcome to work with 10 at a time. That would still be a system. Now, we're going to solve this system. We're going to solve this system. Graphically speaking, to solve the system, it really means, do they ever meet? Do they ever cross one another? Meaning, do they ever have a shared point? So looking at the graph, what do you notice about these two lines? They meet exactly at one point. And if I were to read that point, it would be 0, comma, negative 1. Okay. Let me do a new one. Now, what about in this case? Notice how the lines definitely cross. Where do they cross at? At 0, comma 3. And that should be our answer. Now, what if the lines never touch? What if the lines never cross or meet? Then technically your solution will be no solutions, right? Because it never happens. There's never an x and y coordinate value that will work for both. So what about the second type? This time you actually have to graph them, okay? The nice thing is they're still written in slope-intercept forms. That's really nice. Remember, you only need 2 points to connect the dots to create a line. I'm going to always start with my y-intercept, which is negative 2. Then what's my slope? It's negative x. I'm going to think of that as negative 1 over positive 1. So I'm going to go down 1, then go to the right 1. And boom, that's my line. You can double check your work, maybe plug in another number. What would happen if, I don't know, x was 3? Then that's negative 3 minus 2, and that should be negative 5. Yep, that would be negative 5. Okay, second one, I need to graph this guy. Y-intercept is super easy. Then this time, my rise is 1, my run is 6. Go up 1, right 6. 3, 4, 5, 6. And what do you notice now that you have graphed the two equations? There is an intersection point, and they intersect at negative 6, comma 4. Okay. Last one is level 2, and I'm assuming the only thing is, like, for example, for the second one here, you have options. Since we went through the 3 different linear forms, you guys can keep it in standard form, or you can rewrite it in slope-intercept. But honestly, the point is you just need to graph the 2 lines, right? You already know that there are 2 lines. So let's start with the first. 7 is my y-intercept. Then my rise is 1. My run is 2. Boom, how fast is that? Then here's a second one. Remember with standard form, guys, we could isolate y, meaning get y all by itself and rewrite it in the form y equals mx plus b. Or I can use the fact that this is standard form, which is really neat using x and y intercepts. Please don't forget, we just need 2 points to draw the line. So what I'm going to do is I'm going to think about the x-intercept. For the x-intercept, the y value is 0. So what times 5 is equal to negative 10? That's negative 2. Then now I'm going to do the y-intercept. Y-intercept x is 0. So 2 times what is negative 10? That should be negative 5. And I can check my work a little bit, but basically the same idea. Where do they intersect? Negative 4, comma 5. So hopefully you are now seeing that when we work with systems of equations, we're basically finding the point of intersection. Okay. If you look at the discussion for this week, you'll notice that there's usually three possibilities for answers. There's one solution, no solution, or infinitely many solutions. I'm going to leave that very last possibility to you. We're definitely going to talk about it on Wednesday, but see if you can figure out for me what that would actually represent. All right, well, good luck, guys.